Hi everyone, welcome to serverless application in AWS tutorial. I am Arogya Das. In this tutorial, we will learn about serverless architecture and how to build serverless application in AWS using AWS services such as API Gateway, AWS Lambda, and Amazon DynamoDB. For the web app, I will use React app to insert and retrieve customer data. Hereafter, I will use the term Lambda to refer to AWS Lambda. Now, let's go into the details. Serverless architecture overview. Serverless architecture is an approach to software design that allows developers to build and run applications without having to manage the underlying infrastructure. With serverless application, the application still runs on servers, but the cloud service provider handles the provisioning, scaling, and management of the infrastructure required to run the application. This approach enables developers to increase their focus on the business logic and add more values to the core of the business. To build a serverless application in AWS, the below AWS serverless services can be used. AWS API Gateway as HTTP gateway service and AWS Lambda as a compute service to process the request and DynamoDB as database service to store the data. As you can see in the below image, the client app calls the API gateway and the API gateway routes the request to the Lambda function and Lambda function interacts with the DynamoDB for the CRUD operations and returns the data to Lambda function, and in turn the Lambda function returns the response to the gateway, and the gateway returns the response to the client. Serverless services in AWS. Next, let me explain briefly about the serverless services in AWS for building a serverless application. First, the API Gateway. API Gateway is a fully managed service for creating, publishing, maintaining, monitoring, and securing REST, HTTP, and WebSocket APIs at any scale. It works by providing a layer between API clients and the backend API services and is responsible for enforcing security policies, rate limiting on the API. The API gateway receives client app requests, forwards the request to the backend API service for processing, and returns the response back to the client app. Next, Lambda. Lambda is a serverless compute service that runs code without provisioning or managing servers. It can scale up or scale down depending on the workload demand. One of the main advantages of Lambda is that it is charged only for the compute time consumed and there is no charge when the code is not run. Just for information, AWS Lambda is similar to Function App in Azure Cloud. Next, DynamoDB. Amazon DynamoDB is a serverless, NoSQL, fully managed database and provides single-digit millisecond performance and high availability. It eliminates the scaling and operational complexities of relational database. As a NoSQL database, it provides strong read consistency and ACID, ACID transactions, that is, atomicity, consistency, isolation, and durability for building enterprise applications. CRUD operations, that is, create, read, update, and delete, on tables can be performed using JavaScript object notation and open data interchange format that represents data as a collection of key value pairs. Next, let's see the prerequisites. For this tutorial, you need to have the below setup completed beforehand. First, AWS account. For this tutorial, you need to have an AWS account, and you can create a free tier account, and you can get the account creation URL from the GitHub repository in Readme file. Next, you need to have an IAM user with the necessary privileges assigned. As this is a demo, I have assigned the administrator access managed policy to the IAM user. Another important thing is login as an IAM user and not as root user to avoid potential security issues. Next, installation on the local machine. You need to have installed Git, Node.js, and VS Code, such as for cloning repository, running the React app, and testing the serverless application. The download links are mentioned in the README file of this project in serverless-app-react-aws repository. You need to have the React app deployed locally and running. For this React app locally running, please clone the GitHub repositories to your local folder. For React app, clone the repository named serverless-app-react-aws, and for Python, AWS Lambda DynamoDB Python repository. Next, serverless application hands-on. We will be performing the below activities to build the serverless application in AWS. Amazon DynamoDB. From AWS console, we will create a DynamoDB table named customer to insert and retrieve data. Next, Lambda. From AWS console, we will create a Lambda function with Python as the runtime stack, which we will query and insert data into DynamoDB and send the response back to API Gateway. Next, API Gateway. From the console, we will create a new API Gateway REST API, which will act as a communication layer between the React app and Lambda. Next, the React app. So for this, I have created a simple React app which will query and insert customer information to the DynamoDB table. One important thing I like to share with you, I have created a detailed tutorial video for DynamoDB, Lambda, and API Gateway. You can watch if you want to deep learning into these AWS services. Next, we will test the serverless application. Once the React app starts running locally, we will input the customer data and test and see if the query and insertion are successful or not. And regarding the source code, it's available in my GitHub account and the repository links are given in the description. The complete steps for this tutorial are well described in the README file of this project. So please refer to them. Now let's do the hands-on. I have signed into my AWS account. Now, as a first step, let's create the DynamoDB table. So here, you can enter in the search box DynamoDB, Dynamo. So it will display this service. Click on this service. Then create table. Here, enter the table name. So I will give customer as my table name. Then for the partition key, I will give customer ID as my partition key. And the type I will put it as a string. Then short key I will leave it as blank. Then table settings, please select this custom settings and we will set our own details. So for the read or write capacity settings, I will go for provision since it's less price, and as we are in the free tier, we can use it for free of charge. Next, for the auto scaling, I don't want any auto scaling. So for the read and write, I will put it off. And the other details I will leave as it is and create the table. So still it is creating the customer table. It may take, yeah, the table is created. Now click this actions and go to explore items. Here click this create item button to add a item. So customer ID I will input as 1. Then click on this add new attribute to add a new attribute. So here I will give name as the new attribute and enter a value, and I will leave this type also as a string, and I will add another attribute. So this one I will name as email, because so these three attributes will be referring to the Lambda function. So please be careful when you enter the attribute names. So I will say now click on create item to create one item. So you can see that a single item has been created. Now we have successfully created the DynamoDB table, which we will be accessing from Lambda function, and that data will be retrieved from the React application. Now next, let's go and create the Lambda function. For this, let me open AWS in another tab. Here in the search box, enter Lambda, click on this, then click create a function. So for the Lambda function, I will give the name. Okay, so for the runtime stack, I will select Python 3.13, and for the architecture it is okay. So here one thing we need to note is the permission, the execution role. So usually we will set the create a new role with basic Lambda permissions. So this role will allow Lambda to create CloudWatch log group and write into the log stream. But this time we will be accessing the DynamoDB from the Lambda function. So we need to assign the Lambda the permissions to access the DynamoDB. For this, we will create a new role using this. So click on this create a new role from AWS policy templates and enter the role name here. DynamoDB access. The policy templates, enter simple microservice permissions. So select this as permission. This will allow the Lambda function to access the DynamoDB table. And for the other details, let's leave as it is, the default ones. Then click this create function to create the Lambda function. So this may take a few seconds. Let's wait until the function gets created. Yes, the function is created successfully. Now let's update the code, the default code to the latest the code we have cloned from the repository. For this, I have already cloned the code to my local folder. So I will copy this code and override the existing code. Okay, so that is done. Let me briefly explain the Lambda function. Here, this import JSON and import Boto3. Here we are importing the libraries. Next, this to handle the exception, we are importing the client error. Then using the Boto3 resource API, we are getting the DynamoDB service. And using the DynamoDB service, we are getting the identifying the table name. So here, custom we have created in the DynamoDB the customer table. So that we are setting here. Next, the main function handler, that is the Lambda handler. Here, the event object holds the payload data. Here, we are identifying which HTTP method has been invoked. Then another important thing is, since we will be calling the API gateway from the React app, we need to set the response header, that is CORS response header, cross origin resource sharing header as response. Here we need to allow this access control allow origin header. Here I have put as a star. If you want, you can put your main domain here. Then the access control allow methods, I have put get, post and options. Then the response body. So here, if the HTTP method is get, then we are getting the query parameter, whether it has the customer ID as the query parameter. Then after getting the query parameter, then we are using the get item live API to retrieve the data from the DynamoDB table. So here, this will call the DynamoDB query and get the result here. Then once the result is passed, we are passing this response body all the details. So here result set will have the whole data retrieved from the DynamoDB, and in the result set there will be a key called item. So from the item we are reading all the data and setting it to the data set variable here. Then from data set we are extracting each item here. Next, then we are printing the response body and here returning the response in this location. Next, if it is a post method, we need to the API gateway, from the API gateway the request body will be sent and we need to parse that body and send it to DynamoDB for inserting. Here the JSON loads dot body converts the body into the JSON format. Here we are printing the body. Then in the body here we are identifying each item here. So ID, name, email, all these are passed here and passed. So if it does not, if the request pay body does not contain these items, then it will raise error that customer ID, name, email ID required. If these values are present, if these items are present in the request body, then we are calling the put item API to write into the DynamoDB table. So here we are binding the customer ID key with the ID value and name with the name value and email with the email value. If successfully inserted the data, then it will return the response one item inserted successfully. Else it will return the error. If any exception happens, it will catch that exception and send it back. As we have modified the code, we need to deploy the Lambda function so that the changes will get reflected. Keep in mind that each time you update or modify the code, the Lambda function has to be redeployed. Now let's click this deploy button so that the new code is updated correctly. Okay, so here you can see that the deployment is successful. Next, let's create the API Gateway REST API. Let me open another tab for creating the API Gateway. So in the search box, type API Gateway and this will take you to the API Gateway service. Scroll down and go to the REST API. Click this build button on the REST API and here enter the API name. So after entering the name, the endpoint I will leave regional as it is and click this create API. So once the API is created, next we will create a resource named customer. Click on this resource button. I will give customer as a resource name. And another thing to be noted here is we need to enable this cross origin resource sharing because we will be calling the this will allow, this will add an options method apart from the get or post method that we'll be adding later. So why this is because we'll be calling this API from the React app. That so click on this create resource button and it will create the resource named as customer. Next, we need to create the get method and the post method for this resource. So click on this create method and select the method you want. So we will go for a get method to retrieve the data and the integration type will be Lambda integration and the integration type here whether we want to proxy or non-proxy, I will go for the Lambda proxy integration. So enable this button and here we need to choose the Lambda function as we have created the Lambda function earlier, so it will display here and select this. For the other things, we will leave as it is and click on this create method. So we have created the get method. Next, we need to create another method. So click on this customer resource and click create method. So here select the post method and integration type as Lambda. Again for this proxy integration, select enable this button and again select the same Lambda function and click create method. Now we have created the API with get and post methods. Now what we have to do is as we will be calling this API from the React application, we need to enable the CORS, that is cross origin resource sharing. Click on this button and set these checkboxes enabled. And as you saw in the Lambda function, we are sending the response getters, the below response getters, that is allow access control allow origin and access control allow methods get post options. Here also, so we are setting access control allow methods, all these three, and other things leave it as it is and click on save. As we have created the API, the resource and the methods, next we need to deploy the API to be called from the React application. So click on this deploy API and here we need to select the stage. So we will go for a new stage and enter the stage name. I will put as dev. Then if you want to add a description, you can add it. Then click on deploy. So once the API is deployed, we will get an URL. Copy this URL. We will need it in the React app to call this API. Next, let's go and deploy our React application in the local machine. As we have cloned the repository in our previous steps. We will open that repository in the VS Code, Visual Studio Code, and run the React application. I have opened the React application code that we cloned from the GitHub repository. Now, briefly, let me explain the code. So, this is the main program or the entry point for the React application. So, these two lines, we are importing the React and the Axios library. This Axios is used for to make HTTP request, and the import the React library for writing React components. And here we have declared the response variable and set response function. And this use date is a hook in React that allows to add state to the functional components. So this part will be used for the get method, and this will be used for the post method. This form data variable will hold the fields ID, name, email, values, and they are initialized to blank initially. Next, here we have the API URL. Please do not forget to replace your API Gateway URL here. Now let's go to the AWS console and copy the URL and put it here. Also, after replacing the URL, do not forget to save it. So you need to save so that the change will get into effect. Next, this handle change function. So this will set the values for the form data. And next we have the get data function where we call the get method. Here for this Axios get API, we are passing this query parameter. So from the front end application, React application, we have a customer ID field where we will input the customer ID, and that will be passed as the query parameter. Then we have the handle post method. So for the post method, all we are calling the post API to send the form data. And finally, we have the HTML code where we have designed the fields to input the data. This will be the view customer where we will pass the customer ID to get the data for the particular customer ID. Next we have the add a new customer where we will input the customer ID, name, email, and so on. So once this, as you can see here, this handle change function will be called each time the value is input to the name ID fields. So I think this is a high level explanation of the React code. Next, we need to build the React app to run it from locally. So for this, let's open the terminal, go to view menu and click the terminal, and I will change it to the bash terminal. So here, one thing to be noted is, once we upload the code into the Git repository, the node modules will not be uploaded to the Git repository. So for this, we have to install the node module using the npm install. Let's copy this one and install the node modules. So this may take a few seconds or minutes. So wait until the node modules get installed. Yes, as we can see, the node module installation has been completed. Next, we need to build the React app using the npm run build. So run the npm run build command to build. This also may take a few seconds. and so wait until it gets completed. Yes, as the build is completed, next we need to serve the file from the local HTTP server. For this, we need to run npm install -g serve command. So enter. This also may take a few seconds or minutes. So wait until it gets completed. Yes, it's completed. Next, we will serve the files using the serve-s build command. Yes, now the React app is running locally. Now let's copy this URL and invoke from the browser and check if the application is working properly or not. Yes. So now our simple customer application is running. Let's input the value customer ID. Let me give customer ID as 1 and check if it retrieves the data from the DynamoDB. So click on the search button. Yes, we can see that customer ID 1, name Arvidas, and the email ID has been retrieved successfully. Now we can go to the DynamoDB table and see that the data is retrieved correctly. Yes. So customer ID 1 and the email ID is this and the name is retrieved successfully. Next, let's go and send some data. Say I am entering 2 and I am adding serverless test and sending serverless test 2025 25 at gmail.com. Okay. So now let me click this add button and check. Yes, it says one item inserted successfully. Now let's go and check in the DynamoDB whether the data is inserted successfully. Click on this refresh button. Yes, you can see that the data is inserted successfully. Now let's retrieve the same data in our React application. Let me pass 2 as the query parameter. Yes, you can see that the customer ID 2 and the name and the details are brought properly. Now let me give another ID 3 server test 1 and serverless 1 2 3. Now let me click this add button. Okay, so the message is one item inserted successfully. Now let's go to DynamoDB and check if the item is inserted. Yes, it's now the third item has been inserted. Just for cross verification, let me enter 3 as the customer ID and click search button. Yes, you can see that customer ID 3 is retrieved and the corresponding data has been retrieved. We have completed the serverless application in AWS tutorial with the front end as React app. As we have created many resources for this tutorial, we need to clean up those resources. For this, first we will delete the Amazon DynamoDB, next the CloudWatch logs, then the IAM roles, then the Lambda function, and then the API Gateway. Let's go into the AWS console and delete the resources. I am in the AWS console. Now let's delete the DynamoDB. So click on the tables and select the table and click delete. So it will ask for confirmation and click delete. So this may take a few seconds to delete. In the meantime, let's go to the Lambda function and delete it. So here I am in the Lambda function. Click this one, or you can go to the functions, select this one and click actions, delete. So before deleting the Lambda function, we need to delete the CloudWatch logs. So here, go to configuration, sorry, go to monitor, click this view CloudWatch logs, and this will take you to the CloudWatch logs service where the log streams are created. Let's select this one, log groups, click this log groups and select this one and click actions, delete log groups. So this will delete the log group. And to cross verify, if you click view CloudWatch logs again, so it should throw an error that the resource has been deleted. Okay, so the log group does not exist, it says. That means our log group has been deleted successfully. Now going to the Lambda function, click on configuration, click on the permissions to delete the roles that are created. So here we created the simple microservice role permission for the Lambda to access the DynamoDB. Click on this, it will take you to the IAM service where you will find the related roles. Delete those roles which we created. So we created these two roles, select them and click delete. Copy the name and paste it here and click delete. This will delete the roles. Now if you see the DynamoDB, it should have been deleted. Yes. If we click the tables, there is no table listed here. That means the table has been deleted. Now as we have deleted the Lambda rules created for the Lambda function and the CloudWatch log, now let's delete the Lambda function itself. So select the function and click delete. And here type confirm and click the delete button. It will delete the Lambda function. So we can see that the Lambda function has been deleted. Now finally, let's delete the API gateway. Go to the API gateway, click APIs, select this API and click delete. So I enter confirm and click on the delete button. This will delete the API. Finally, we have deleted all the resources that we created for this demo. That's all in this tutorial. Thank you very much for your time and patience in watching this long video. A simple request, please like, subscribe and share to your friends if you found this video useful. Thank you very much once again.